Hi, I'm Patrick Reagan. Welcome to the Network Router and Routers Part 2, Routing Protocols Part 1. In this video, we continue our discussions on routers and routing by focusing on the characteristics of routing technology, including static and dynamic routing and route selection. As always, stick around for the practice questions at the end, test your knowledge, and help you prepare for the Network Plus exam. If you find this video helpful, don't forget to click the like button, and if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Routing is the process of selecting the best path for data packets to travel across the network from their source to their destination. It decides which route to take to reach a specific network or device based on factors like distance, traffic conditions, and cost, and is typically performed by dedicated devices called routers, which use routing tables to make these decisions. Routing protocols are designed to select the best optimal path for data transmission based on metrics like hop count, bandwidth, delay, cost, and so forth. When selecting a route, routers consider metric, administrative distance, and prefix length. The routing metric is the criteria or value used to determine the optimal path. Routing metrics are values assigned to each route to indicate the cost or quality of the path. Common metrics include hop count, which is the number of routers the packets must pass through, bandwidth, which is the available data transfer capacity of the route, delay, which is the time it takes for a packet to travel through the path, reliability and load, which includes other factors that may affect the route quality, and cost, which is a generic metric that represents the expense of using a particular link where the administrators assign the cost to each link. Cost can be manually configured to favor certain routes over others based on administrative preferences. Administrative distance is a measure of the trustworthiness of the source of a route. A lower administrative distance is better, with a range of 0 to 255 for Cisco routers. For example, for Cisco routers, the default administrative distance for a static route is 1, while the default for a DHCP Learn Default route is 254. It should be noted that subnets connected directly to the router are assigned a value of 0. Other vendors may use their own scale for default administrative distances. When a router learns about a destination from multiple routing protocols, it compares the administrative distances and chooses the route with the lowest distance. If all three attributes are identical, the router will load balance across the available paths. In routing, prefix length is the number of leading bits in an IP address that define the network portion. Longer prefixes are preferred over shorter ones because the longer the prefix, the fewer their hosts. Fewer hosts indicate a more defined network. A /24 subnet is inside the /16, and by specifying the /24 subnet, you're narrowing down the destination. Routing table stores a list of routes. Routers maintain routing tables which store the best known routes to various destinations along with the associated metrics such as distance and next hop. The routing table contains the next hop address for each destination, specifying where to send packets next. Routing tables usually contain a default route, also known as the gateway of last resort. This catch-all route directs packets when a more specific path to the destination is not explicitly listed in the routing table. In a routing table, a default route is defined by the destination IP address 0.0.0.0/0 and IP version 4, or ::/0 and IP version 6. A router always tries to find the most specific route first using the longest prefix match method. If no specific route is found for a packet destination, the router will use the default route. If a default route is not configured, any packets without a specific route in the table are dropped. Routing algorithms can be divided into static routing, which is a network routing technique where the routes or paths to different networks are manually configured on routers by a network administrator. Static routing requires manual intervention to define and modify the routing table. Dynamic routing uses algorithms to automatically adjust paths based on network conditions. When manually configuring static routing, network administrators manually enter the route information into each router. This includes defining the destination network, the next hop IP address or exit interface, and sometimes additional parameters like metric or administrative distance. The static routes are stored in a routing table. The routing table contains all the routes that a router can use to forward packets to their destinations. When a packet arrives at the router checks its routing table to determine the best path to forward the packet. In this case of static routing, the router will use the pre-configured static route to determine where to send packets. Since it's a static routes do not automatically adapt to changes in the network, such as a failed link. The topology changes, such as a link goes down, the administrator must manually update or remove the affected routes. Here's an example of 3 routers, each with its own routing table. The routing table shows what is connected directly to the router and a list of remote subnets and the next hop to get to the remote subnet. If PC1 needs to communicate with PC2, it will send the packets to its default gateway. It will usually determine that 10.3.3.100 is on a remote subnet and sends the packets to the default gateway, which is 10.1.1.1. The router will look at the router 1 routing table and determine to get to the 10.3.3.0 network, it has to be sent to 192.168.12.2. This packet is then sent to router 2. Router 2 looks at the routing table and sees that to get to 10.3.3.0, the packet has to be forwarded to 192.168.23.3. The packet is then sent to router 3. Router 3 looks at the routing table and sees that the 10.3.3.0 is connected to the router, which then sends it to the 10.3.3.100 via the MAC address via the switch to PC2. The advantages of static routing include simple to implement and understand, no need for CPU or memory resources for updates, and useful in small or stable networks. The disadvantages of static routing include it requires manual configuration and management, no automatic failover or route recalculation, and not scalable for large or frequently changing networks. Dynamic routing is a technique used in computer networks where routers automatically discover and maintain routes in the network using router protocols. Dynamic routing allows routers to share information about network topology changes and automatically update their routing tables based on this information. Dynamic routing is more adaptable than static routing, making it suitable for larger or more complex networks where paths might change frequently due to network conditions such as link failures or load balancing. In dynamic routing, routers use specific dynamic routing protocols to communicate with each other and share information about network paths. Some common dynamic routing protocols include Routing Information Protocol or RIP, Open Shortest Path First or OSPF, Enhanced Interior Gateway Routing Protocol or EIGRP, and Border Gateway Protocol or BGP. BGP is the routing protocol used on the Internet. RIP will be discussed in this video, and the others will be discussed in Part 2. In dynamic routing, routers will exchange of routing information, where routers periodically exchange routing information such as reachable networks and paths with their neighbors using these protocols. This information is used to update their routing tables, ensuring that each router has the most up-to-date knowledge of the network's topology. Automatic path selection is where the router uses the information provided by the routing protocol to determine the best path for sending data packets. If network conditions change, such as the link fails, the router automatically selects a new best path based on the updated information. Convergence is after a topology change, such as the link going down. Dynamic routing protocol takes time to reach a state of convergence where all routers in the network have consistent routing information. Faster convergence is a key goal for routing protocols, especially in large networks. The advantages of dynamic routing include automatic updating and maintenance of routing tables, adapts to network changes including link failures, scalable for large and complex networks, and allows for load balancing and redundancy. The disadvantages of dynamic routing include higher resource consumption including CPU, memory, and bandwidth, requires more complex configuration and management, convergence times can vary affecting packet delivery, and potential for routing loops or suboptimal paths. As mentioned before, convergence time refers to the time it takes for all routers in the network to reach a consistent understanding of the network topology after a change, including link failures. Faster convergence is critical for minimizing disruptions. Routing protocols like OSPF and IGRP converge quickly. Older protocols like RIP can take longer to converge, potentially leading to network inconsistencies, particularly when a link goes down. Scalability is the ability to handle growth. Routing protocols should scale with the size of the network. Some protocols, such as BGP and OSPF, are designed for large, complex networks, while others, like RIP, are more suited for smaller networks due to the limitations in handling large routing tables or frequent updates. Loop prevention is when routing protocols must prevent situations where packets get stuck in an endless loop between routers. Techniques like split horizon, route poisoning, and hold down timers help prevent loops in distance vector protocols. Link state protocols inherently avoid loops by having each router maintain a full view of the network topology. Dynamic routing can be divided into distance vector routing and link state routing. With distance vector routing, routers share their routing tables with directly connected neighbors. It has slower convergence and can be prone to routing loops due to the routing by rumor concept where information is not always accurate. It's usually automatic and requires little configuration. It is based on how many hops away in another network, which is the distance vector. Examples include Routing Information Protocol, or RIP. Link state routing is where each protocol broadcasts a complete picture of its connected links to all other routers in the network, allowing for more comprehensive understanding of the network topology and faster convergence times. Link state builds a complete network map which can quickly adapt to network changes, joined to which the comprehensive network view. It considers the speed of the network. It requires more processing power to maintain and calculate routes based on the entire network topology. Examples include OSPF. Hybrid routing is protocols like EIRGRP, which combines characteristics of both distance vector and link state routing. Routing Information Protocol, or RIP, is one of the oldest and simplest distance vector routing protocols used in computer networks. It allows routers to exchange information about the best path to reach specific network destinations. RIP is primarily used in smaller networks due to its simplicity and limitations. RIP operates using a distance vector algorithm where the hop count is used as the metric to determine the best route. Each router in a RIP-enabled network shares in its routing table with its directly connected neighbors at regular intervals, typically every 30 seconds, and router updates their routing tables based on the information they receive. Hop count metric is where RIP uses the number of routers a packet must pass through to reach its destination, which is known as the hop count, as the only metric to determine the best path. The network shown in the figure has 3 routers from the sending host to the receiving host. The top route is 5 hops, the middle hop is 4 hops, and the bottom path is 3 hops. Route 3, which only has 3 hops, is the shortest route. The hop count has a maximum limit of 15, which means if the destination is more than 15 hops away, RIP considers it unreachable. This makes RIP unsuitable for large networks. Since it's only based on hop count, if there's a better route available with better bandwidth, then it will not select that route. Product updates is when routers running RIP send out routing updates to the neighboring routers every 30 seconds. These updates contain the router's current routing table. Each router receiving the updates checks if any better or lower hop routes are available and updates its routing table accordingly. Bandwidth utilization in RIP is very high as it broadcasts its updates every 30 seconds. Here you have 4 subnets with 3 routers. Each router is connected to 2 subnets. The initial routing tables show the networks that the router is connected to. When router 1 sends its updates, it will tell router 2 about the 10.1.0.0/16 subnet. Router 2 calculates that the 10.1.0.0/16 subnet is 1 hop away. When router 2 sends an update to router 1, it will tell the router 1 about the 10.3.0.0/16 subnet. Router 1 calculates that the 10.3.0.0/16 subnet is 1 hop away. When router 2 sends an update to router 3, it will tell the router 3 about the 10.1.0.0/16 and the 10.2.0.0/16 subnets. Router 3 calculates that the 10.1.0.0/16 subnet is 2 hops away and 10.2.0.0/16 is 1 hop away. After a few more updates, all routing tables are complete that list all of the subnets, which means all of the routers are converged. However, if a router fails, a router is added, or an additional subnet is added, the convergence process will start again with the sent updates that will eventually update the routing tables. RIP is still used today, although rarely and primarily in very small, simple networks or for educational purposes due to its simplicity, ease of use, and legacy status. It has been largely replaced by more advanced protocols like OSPF and EIGRP in larger environments because of its limitations, such as the slow convergence and low scalability, which makes it unsuitable for complex networks. Question: which of the following routing protocols has routes that are classified with administrative distance of 1? Answer: static routes. Question: which of the following routing protocols has routes that are classified with administrative distance of 110? Answer: OSPF. Question: you have a router with an OSPF route and a static route DSL connection to be used as backup. You notice all traffic is going over the DSL connection, although you verified that the OSPF connection is operating correctly. What should you do to get traffic to use the OSPF route? Answer: increase the administrative distance of the DSL connection. Question: which of the following statements is true? Choose 2 answers. Answers: distance vector routing share the routing table with directly connected neighbors, and link state routing share the routing table with all other routers in the network. Question: what type of routing is based on you manually configuring the routes in a router? Answer: static routes. Question: which type of routing is based on automatically adjusting routing paths based on network conditions? Answer: dynamic routes. Question: what is the maximum number of hops that RIP routing support? Answer: 15. For more information, refer to these sites. In summary, routing is the process of selecting the best path for data packets to travel across the network from their source to their destination. The routing metric is the criteria or value used to determine the optimum path. Routing metrics are values assigned to each route to indicate the cost or quality of the path. Administrative distance is a measure of the trustworthiness of the source of a route. Routing table stores a list of routes. Routers maintain routing tables which stores the best known routes to various destinations along with associated metrics such as distance or next hop. Static routing is a network routing technique where the routes or paths to different networks are manually configured on routers by a network administrator. Static routing requires manual intervention to define and modify the routing table. Dynamic routing uses algorithms to automatically adjust paths based on network conditions. Routing Information Protocol, or RIP, is one of the oldest and simplest distance vector routing protocols used in computer networks, which has a maximum of 15 hop count. Thank you for watching this video. The next video will be Network Routing and Routers, Part 3, Routing Protocols, Part 2. If you like this video, click the like button, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.